In this video, we're going to talk about how to calculate molar mass. So what is molar mass? Molar mass is the mass that is in 1 mole of any type of substance, whether you are talking about a mole of an atom or a mole of a molecule, and we express it with the units grams per mole. Just as a reminder, a mole is a counting number, such as a dozen would mean 12 items, a pair would mean 2. A mole is also known as Avogadro's number and stands for 6.022 times 10 to the 23rd of anything in chemistry, though we use it generally to talk about atoms and molecules. Now you can find the molar mass of an element on the periodic table. So all elements have 2 numbers. One of them would be the atomic number, which is located near the top left-hand side, and that's the number of protons there are. The other number, in this case, in this periodic table, it's located underneath the name of the element. That is the atomic mass, which would be the mass of just one atom of that element, or it can also mean the molar mass, which is the mass of 1 mole of an element. If you are talking about molar mass, for example, potassium, its molar mass is 39.10 grams per mole. If you were talking about just the mass of an atom, it would be 39.10 atomic mass units. So slightly different. The numbers are the same, but the units would be a little different depending on what we're talking about. So if you wanted to calculate molar mass of a molecule, you can do that by counting up the number of atoms in your molecule and then adding them all up together. So for example, CO2 is made up of 1 carbon and it's made up of 2 oxygens. If you look at the periodic table, carbon has a molar mass of 12.01 grams per mole, and oxygen has a molar mass of 16.00 grams per mole. Using those numbers, you'll just add 1 carbon, so 1 times 12.01 grams per mole, and then add the molar masses of 2 oxygens, giving you 44.01 grams per mole in a mole of carbon dioxide. Let's take something a little bit harder, such as the molar mass of magnesium phosphate. Once again, you would look to see how many of each atom you've got. In this case, we have 3 magnesiums. That 2 next to that phosphate means that there are 2 phosphates. So you would distribute the 2 for the phosphorus as well as the oxygen. So if 1 ion of phosphate has 1 phosphorus, then 2 of them would mean that you have 2 phosphoruses. Oxygen, if each phosphate has 4 oxygens, then if you have 2 of them, you'll have 8 oxygens. So looking back at the periodic table of elements, we look at the molar masses of magnesium, phosphorus, and oxygen. And we will plug in those numbers into our equation. So that would end up being, so with 3 magnesiums, we would take magnesium's molar mass, 24.31 grams per mole, multiply that by 3, add that to phosphorus's 32.07 grams per mole for each phosphorus. There's 2 of them, so we multiply that by 2, add that in, as well as 8 oxygens, giving you a molar mass of 265.07 grams per mole. So just some extra tips. Some really important things is really to make sure that you count the number of atoms correctly. Remember that when you have, like in that magnesium phosphate, you have, if you're talking about 2 phosphates, make sure that you distribute those numbers. Also, don't round too early because we're going to be adding up the masses. You don't want to add up, the mass of magnesium to the ones place. You want to make sure that you're going to at least the hundredths place for that. When you round too early or just too much, that introduces a lot of error into your calculation. And last thing is to make sure that you include units. So that's basically how you calculate molar mass.